Hello again, Daniela. I'm going to try to answer the questions that you just sent me, starting with question 16 on the test three review. All right, so on question 16, we have a function f of p equals negative 50p squared plus 1700p minus 12,000, where p is the price that you set for something, and f of p calculates the profit that you make. And we're asked three things. A, find the price that generates the maximum profit. B, find the maximum profit. And C, find the prices that break even. And what it means to break even is profit is equal to zero. You don't lose money, but you don't make money either. Now, the trick to all of these is to remember that the graph of something like this, the graph of a quadratic function, is a parabola, and the negative in front makes the parabola upside down. So you're actually texting me right now as I'm making this video. So the graph of this will look something like that. But for this function, the thing that goes in is the price. If I can spell price. And the thing that comes out is the profit. So from a visual perspective, you're talking about the maximum profit. You're talking about this point right here. And that point, if you can find it, then this would be the price, and this would be the highest profit that you can make. Now, this is the vertex. So to answer the first two questions, we need to find the vertex. So we'll do that in just a second. Now, the break even is where the profit is zero, where the profit is equal to zero at these 2 points. And those are your x-intercepts. If I can spell, these are your x-intercepts. X-intercepts. And so for part C, we need to find the x-intercepts. And that means we need to solve the function equal to zero. So yeah, the hardest part is figuring out how to get what you want. But once you figure out that, we just need to find the vertex for parts A and B, and then we need to find the intercepts for part C, then we can just do the math, which we'll do on the next page. All right, let's start by figuring out the vertex. The vertex is a formula. It's negative b over 2a, comma f of negative b over 2a, where a is the number in front of the x squared and b is the number in front of the x. Now, this isn't x's, this is p's, but it doesn't really change the process. Our function is f of p equals negative 50p squared plus 1700p minus 12,000. And so in this problem, a equals negative 50 and b equals 1700. So when we figure out negative b over 2a, we get negative 1700 over 2 times negative 50. That's negative 1700 over negative 100. Then the negatives cancel, and then when you divide, you get 17. And then that's the first part of the vertex. The second part, we just put 17 into our function, f of 17. We go back up here and we replace all the p's with 17. Negative 15 times 17 squared plus 1700 excuse me, times 17 minus 12,000. And if you carefully put that into a calculator, negative 50, come on, negative 50 times 17 squared plus 1700 times 17 minus 12,000. We get 2,450. And what that means in terms of this graph back here is that we now know where the high point is. So just redrawing that graph real quick. This high point is 17, 2,450. But remember that this was price and profit. And so now we know the answers to the first two questions. The first question was find the price that generates the maximum profit. That would be $17. I assume this is in dollars. Let me look at the picture you sent me. Got about 3 text conversations going on right now. Let's see. Price, let's see, P is a price per shirt. Doesn't say if it's in dollars or not, so we can just assume it's in dollars. So when the price is $17, we hit a maximum profit of $2,450. I'm going to type in words what I just said. When the price is P equals $17, assume it's $17, we get a maximum profit of, and I'm just going to type the function part, f of 17 equals $2,450. So now we know the answers to part A and part B. The answer to part A is 17. The answer to part B is 2,450. This is our monthly profit, by the way. As far as the break even, we need to know when the function is equal to 0. So for part C, we need to solve negative 50p squared plus 1,700p minus 12,000 is equal to 0. And there's 2 ways to do this. You can either use the quadratic formula or try to factor. I'm going to solve this by factoring, although you're welcome to get out the quadratic formula. If I were solving this by factoring, the first thing I would notice is that all 3 of the numbers are divisible by 50. The reason I know that is because these 2 numbers, the last 2, these 2 are clearly divisible by 100 because they both end in 2 zeros, but 100 is just 52 times over. So everything should be divisible by 50. So I'm going to start this. I'm going to factor out negative 50. And again, this is because I choose to solve by factoring. If you want to use quadratic formula, you are welcome to. Let's see, if we factor a negative 50 out, that means we're going to divide everything by negative 50. Well, the first term just loses its negative 50. And the second term, if we divide 1,700 by negative 50, we should get negative 34. I better double check that. 1,700 divided by negative 50 is negative 34. And on the other one, if we divide negative 12,000 by negative 50, we get positive 240. And at this point, if you are trying to factor, it might be tricky to factor this because you would need 2 numbers whose sum is negative 34 and whose product is 240. But just glancing at it, I see what they are because I just, oops, wrong variable. Because I was thinking of 240 as 24 times 10. Well, those add up to give 34. And if I make them both negative, then they add up to give negative 34 and their product is still 240. At this point, it's factored. So we set each factor equal to 0. P minus 24 is equal to 0. P minus 10 is equal to 0. And we get a price of $24 and a price of $10. These should be the same answers you get if you use the quadratic formula. What this tells us is that if we set a price of $24, we're going to break even. We're not going to make anything. We're not going to lose anything. Or if we set a price of $10, we'll also break even. All right, let's take a look at the next one that you asked about. All right, question 28 says to use the remainder theorem to determine if the number is a 0 of the polynomial, f of x equals 2x to the 4th plus 6x to the 3rd minus 12x squared plus 16x plus 96. And we're given c equals 3 and c equals negative 2. Well, first off, make sure you understand what it means by the number is a 0 of the polynomial. What this means in general is this means when I put the number into the function, it's equal to 0. Okay. The remainder theorem says that this is the remainder theorem. There's 2 things going on here. There's definition of the 0 of a polynomial, and there's also the concept of the remainder theorem. The remainder theorem says the following. It says that the remainder, let me type this out because I can. It says, come on. There we go. The remainder of f of x, and I can't, 1 second, let me go get a division sign here. Let's see, I got to go into Microsoft Word and steal one. Let's see, division sign is right here. Okay. All right. The remainder of f of x divided by x minus c equals f of c. That's what the remainder theorem is saying. Okay, so if we put all this together, we're looking to see if sticking these numbers into the function equals 0, which is like asking if the remainder is equal to 0. So if we put all this together, what we're really being asked is the remainder 0? To check this, just put each number in the box in synthetic division as is. It's a little bit tricky because, and I just got something backwards there. Sorry about that. It should be x minus c. I typed c minus x. But it's a little bit tricky because if you just focus on these parts that I threw out here, this part, and this part, the c sometimes looks positive and sometimes it looks negative. Looks positive here, looks positive here, looks positive over here too, but it looks negative right here. And it makes it tricky to know whether or not the number that you're given should be used as is, or if you should change the sign. And there's a simple rule for that. If you're playing any of these games, sticking a number to a function, sticking a number into the box in synthetic division, or sticking it into a factor right here, there's one rule that ties it all together. The only time you change the sign is when you go in or out of the factor. So whenever you put the number in this factor or take it out, you change its sign. Otherwise, you don't. So if I were to check this and put it into the box in synthetic division, I'm not putting it in or taking it out of this factor, which means I don't change its sign. So we're just going to put 3 into synthetic division and -2 into synthetic division. All right, I've got the synthetic division set up. There were no missing terms, so I didn't need any zeros, and we're going to, in the top row, and now we're just going to run 3 through the synthetic division and see if the remainder comes out 0. I'm going to go through it fairly quickly, but I'm going to call out the moves. Start by bringing down the first 2, multiply by what's in the box. 2 times 3 is 6. Add this column to get 12. Multiply by what's in the box. 3 times 12 is 36. Add these to get 24. And I can already tell this is not going to give me 0 because everything's positive from this point forward. 24 times 3 is 72. Add these to get 88. Let's see, 3 times 88 is 264. And when I add these, I'm going to get a big number. I'm going to get 360. But the important thing is that this is not 0. That's supposed to say not. That's supposed to be a 0. So that means the answer to the first question is no. And then we check -2 as well. So we're going to check -2 by just erasing all the red numbers here and doing it again with -2. All right, let's put -2 in the box. I get the feeling this one will be yes. I don't know why. Bring down the first number, multiply by the box. 2 times -2 is -4. Add to get 2, multiply by the box. 2 times -2 is still -4. Add to get -16, multiply by what's in the box. -2 times -16 is +32. Add these to get 48, multiply by what's in the box. 48 times -2 is -96. And finally add to get 0. So this one is a yes. So there's a lot of things being tied together in this question. Now let's get right to the short of it. You could have just put the numbers in here, put 3 into the function, put 3 in here, see if it comes out 0, put -2 in here, see if it comes out 0, because that answers the question. That answers the question. Is the number a 0 the polynomial? The remainder theorem part is just about using the synthetic division to get the same results at the end. Let's take a look at the next question. Next question you asked me was question 32. Write a polynomial that satisfies the following: lowest degree, 0 of -4 with multiplicity 3, 0 of 1 with multiplicity 1, and f of 0 is equal to 320. There's two key things you need to know about this problem. Key thing number one. Let's see, I want to put this in red. If x equals c is a 0, then x minus c is a factor. So that's the first thing you need to know. And you also need to know that the multiplicity is the power. Multiplicity is the power on the factor. I knew that was going to make a line break there. I don't think I can fix it. Well, how about this? If x equals c is 0, then x minus c is a factor. The multiplicity is the power in the factor. So let's start with those two things, and then we'll worry about the last thing, f of 0 equals 320. All right, so when we build this function, all we have to do is set up a factor for each 0. For -4, we would set up x minus -4. Well, let's be honest, when you do minus a negative, it always becomes a positive. So let's just get right to it and call it x plus 4. And the multiplicity was 3, so it would have a power of 3. And a 0 of 1, means that we'll have a factor of x minus 1. And the multiplicity is 1, so we have a power of 1 on that factor. That 1's not really necessary. Now, this technically is a function that satisfies the first conditions, but maybe not the third one. The last one, I should say, f of 0 equals 320. Because if we put 0 in right now, watch what would happen. We would get 0 plus 4 cubed times 0 minus 1. Well, that's equal to 4 cubed times -1, and that's equal to -64. Which is not the number that we want. Now, how do we fix this? Well, we can put any number we want in front of this polynomial. And it won't change the zeros. So I'm going to throw some unknown coefficient in front. I don't want to call it c because I've already used c for something else. Let's just call it a for whatever reason. So there's some number parked out there. Now, if I don't know what that number is, it's just going to get dragged along all the way. And it's going to show up on the end and have -64a, but I need this to equal 320. I need that. Well, right now I know that f of 0 is equal to this guy because I don't know the number that might be in front of all those factors. Well, the only way I can have it both ways is if this is equal to that. So we set up 320 equals -64a, and then we would divide both sides by -64. And you end up getting a equals -5. So it's like the missing piece of our function. There could have been a number in front, and it ended up being -5. Now, unfortunately, this problem isn't over. What we have so far is f of x equals -5 times parentheses x plus 4 to the third power times x minus 1. And this does all the things it's supposed to do. It has -4 as a 0 of multiplicity 3. It has +1 as a 0 of multiplicity 1. And f of 0 equals 320. However, as I discovered in the homework, it won't let you type this because it doesn't want the parentheses. It wants you to multiply all this out. Now, how do we do that? Well, in short, very carefully. First, we would have to multiply or write out all 3 of the x plus 4s. And when you do a FOIL problem, you can only FOIL 2 parentheses at a time. So what I would do here is I would FOIL these to make it 1 set of parentheses, and also FOIL these to make it 1 set of parentheses. I'll spare you the details. The first FOIL problem is x squared plus 8x plus 16. The second FOIL problem is x squared plus 3x minus 4. And we still got the -5 in front. And now to get rid of the rest of the parentheses, we have to do the distributive property 3 times. We first have to distribute the first term of the first factor across all 3 terms of the second factor. So in other words, we've got to multiply x squared times this, and that. Let's just take them one at a time, starting with x squared times x squared. All right. We still got the negative and 5 in front. Don't forget that. Okay. X squared times x squared is x to the fourth. Now let's move over to the next term. Let's make that box a little bit wider. X squared times positive 3x is positive 3x to the third. And then to the last part of this distribution, x squared times negative 4 is negative 4x squared. And then we do it all again, except this time we're going to distribute the next term over here, the positive 8x. So let's get rid of all these little arrows here. And this time we'll do them in green. We need to distribute across all three of these, starting with positive 8x times x squared is positive 8x cubed. And then move to the next term. Positive 8x times positive 3x is positive 24x squared. And then move to the next term. Positive 8x times negative 4 is negative 32x. Didn't leave myself enough room for what's going to be all of the answers, so we'll just move all this over. Okay. All right. And now we have to distribute the positive 16 to all three terms. We'll do these in brown. Positive 16 times all of these. Starting with positive 16 times x squared is positive 16x squared. Then moving to the next term, positive 16 times positive 3x is positive 48x. And then finally, to the last term, positive 16 times negative 4 is negative 64. And that finally completes all of the distributions that we have to do to get rid of that last set of parentheses, except guess what? We still have a couple of things to do. Number one, we've got like terms we need to combine inside the parentheses, and then we have to distribute the negative 5. It's a lot of work to get through this problem. This is why it's important to write out your work on your test, because there's so many steps here. I want to be able to review your work in case you make a mistake. Just moving all this up so that we can finish this. Now, during this, you sent me pictures of 2 more questions. I'm going to have to make a video for them later because I have to teach a class in person here soon. All right, let's gather like terms. I'm going to do what I call catch and circle and cross out. I'm going to circle all the like terms, write them down, cross them out when I'm done. Let's start with x to the fourth, wrong color. Let's start with x to the fourth. This is the only x to the fourth term. If you look across, there's no more. So we'll just bring that down because it's the only x to the fourth term. And now let's cross out that because we're done with it. And now let's find our x to the third terms. There's an x to the third term, and there's another one right here. Those are the only x to the third terms. So we combine them. Positive 3x to the third and positive 8x to the third is positive 11x to the third. And now we are done with those, so we'll cross them out. And now let's find our x squareds. There's a negative 4x squared, wrong color. There's a negative 4x squared. There's a positive 24x squared. And there's a positive 16x squared. And if we put all of those together, we get positive 36x squared. And now we are done with those. Now let's find our x terms. There's a negative 32x and a positive 48x. And when we add those, we get a positive 16x. We are done with those. And lastly, our constant terms, but the only constant term is the negative 64. So negative 64, close the parentheses, and we've now gathered all the like terms. Now we're still not done because we have to distribute the negative 5, but I want to say that's fairly trivial because distributing this negative 5 across all of these is just going to multiply everything by 5 and change everybody's signs. So our final result ends up being, I think I can fit it in here, negative 5x to the fourth. Negative 5 times 11 is negative 55x to the third. Negative 5 times positive 36 is negative 180 x squared. I might make it. Negative 5 times positive 16x is negative 80x. And of course, the last number is not going to fit. Not a problem. Let's grab all this, move it over. And then negative 5 times negative 64 is positive 320. So as you can tell, it is a very, very, very long journey from the beginning of the question to the end, which is why you should write your work down and send me pictures when you finish your test. I'll make a video for the other two questions you sent me after my next two classes.